My name is Yuzhulu. I work on front-end graphics. Today I'm going to talk about some of the interesting topic, customize the 2D and 3D rendering with GLSL. So what is GLSL? GLSL is OpenGL Shading Language, a piece of program running on GPU, and Mathematica graphics has the support to allow user and the developers provide this GLSL file to customize 2D and 3D graphics through SurfaceAppearance. And there are many features built on top of that. And today, I'm going to give some rough introduction about SurfaceAppearance and the features implemented with SurfaceAppearance. And then I'm going to walk you through a very simple example to show you how to use SurfaceAppearance. And there are a few updates about our SurfaceAppearance and the SurfaceAppearance features. I will list them. And last, we'll show you what you can do with SurfaceAppearance. So then what is SurfaceAppearance? SurfaceAppearance and internal functions allows users to provide a GLSL program to customize the GPU behavior for both 2D graphics and 3D graphics. So, and other than the program, you can also allow the associated GLSL program to access the data from box, data from primitives, like a position, option values like a normal, colors, vertex, texture, coordinates, and the directives, and the system metrics. So here is a whole list of the features that are implemented with SurfaceAppearance. All the shadings, fillings, and the CSG region, drop shadowing, blurring, haloing, they are all built on top of SurfaceAppearance. This gives you some rough idea that it is flexible and powerful enough that to do something interesting. Together with this notebook, you are also going to get a notebook called SurfaceAppearance.nb. It is a ref page for SurfaceAppearance object, and it gives have some simple examples and list all the attribute types and the parameter types and the predefined values. It has all the details, and after the talk, you can go through the notebook and play with it. And here I'm going to give some rough introduction about the process, how you add a new SurfaceAppearance definition, the structure. So it need to have a name so that you can reference it later. And you need to tell the program what kind of data you are going to use. For example, you are going to use like a vertex data, you're going to use in normals, colors, and texture coordinates. Other than that, attributes, you can also pass along the parameters to GPU. It could have different types of float, integer, and a matrix, and even a texture. And of course, you need to pass along the GPU program as well, vertex programs and the fragment program. And this notebook has some built-in text asset, and you can just use it to export as a GLSL file. And here I'm going to show you how to add this with these built-in, with these two simple examples, how to add a simple gray level texture mapping functionality. Again, here, give the name, tell the data, like you're going to use position using texture coordinates, and also you're going to use the system transformation together with the fragment shader and vertex shader. So this is how the overview of this definition. Has the name, attributes, have the parameter. If there's more, it will list it here, and also the shaders. Let's take a look. What the shaders do? It has two. It has the vertex shader, the fragment shader. The vertex shader is do operations at the vertex level. A fragmented do the pixel level. Vertex level, here the operation is straightforward. Apply the transformation matrix to the position so that it will show up at the right position. And then we also pass along the texture coordinates. For the fragment shader, it does is sample the texture and then do some simple computing. Here we just turn it into grayscale, and straightforward enough. We have everything. Then next, you need to add this definition into the library. Add the SurfaceAppearance definition. So you can add it multiple times while you are doing improvements, and only the newer one will override the older one. And after that, you can use list the SurfaceAppearance definition to check if it is added successfully or not. If failed, it will just return failed. Otherwise, it will list all the details, including all the fragment shader and the vertex shader. Now, everything is there, and you can just use them. You can use it through SurfaceAppearance and reference through the name you give. And if there's parameters, you can just pass along the parameter values here as well. It will go to the GPU directly. And so here's the results. And what it does is just texture mapping, but in a customized way, it turns the texture into gray level. And also, the nice thing is, with that, all the interactivity just works. And it works with the customized rendering you defined. Next, I'm going to talk about the recent updates about SurfaceAppearance and SurfaceAppearance-based features. Like for haloing and drop shadowing, the rendering quality has been improved. It now has much better anti-aliasing quality. This is especially important for small objects like the text and lines and arrowheads, so that for small, tiny text, still readable. And these are the line and the arrow examples, and you won't see those alias artifacts. It gets much better. For the 3D surface appearance-based shadings now, it renders much faster with transparency. It does have the hardware depth peeling technology, and it will do the sorting on GPU instead of on CPU previously. And it's much more responsive now. And we also added a bunch of new predefined values for SurfaceAppearance, like dark mode, depth peeling related resources, DPI related resources. So you can doing something different that you want to customize the light dark mode, you want to customize the depth peeling, you can do it now. Yeah. And very recently, we also added utility functions to allow user and developers to convert GLSL to other shading languages like SPLV, meta shading languages, HLSL for DX. Yeah, and these kind of functionality are very important if you are working closely with those shaders, or you're working with SurfaceAppearance. Now I'm going to give you the simple example with this customized the gray level texture mapping, and I'm going to convert it to different shading languages. The function, it is called the convert GLSL shaders. It has you can provide the file name, and also tell it is fragment shader, and and it is an OpenGL source, and the target shaders will be one of these. And here it is. And this is a compiled and converted SPLV binary, and the GLSL. You can see that the converted GLSL is a little bit different from the original one. And this is the OpenGL ES version. And this is HLSL. HLSL for DX12, for Meta Shading Language, and for iOS. For this, you can see that the converted shaders are very human-friendly. It's very readable, and it could be very important. And you can also use this functionality to check your existing GF program are valid or not. If not valid, it won't compile, it won't convert, it will just return failed. Same thing for vertex shaders as well. And see, here we apply the matrix, and this is the SPLV code and the GLSL converted, and this is the OpenGL ES version, and very readable. With this functionality, we now have improved all the surface-based features on Windows, and they are now can render natively on with DirectX 3.11 on Windows. How does it work? We just took the program and converted it to HLSL, and to make it work with our D3D11 join layer, and also the data structure we have. So with this, you might notice it will have better rendering quality on Windows, all these surface-based graphics features, and also for those Windows machines without OpenGL support, SurfaceAppearance and the SurfaceAppearance-based features now also works there. So what does this SurfaceAppearance means to you? Which means probably you can also do something interesting, or there's always something you probably want. And here are some examples. Sometimes you might want to do some multiple paths of rendering, and you still want to keep the interactivity. For example, like here, you want to apply both drop shadowing and blurring to the same object. And in the meantime, you want to also keep the interactivity there. And of course, it also works with some customized rendering as well. Here, we added a new feature called bad TV. It just simulated the older time TV has very bad random noise of the signal. And we can combine it together with like a Halloween. You can see that, yeah, it just works. And the nice thing about it is just all the interactivity still works. And same thing for 3D as well. There are things like image effects or post-processing you want to do about your 3D graphics. You can also do it, and it will still preserve all this is the drop shadowing and this blurring applying to 3D graphics, and all the interactivity stays. Here's an example to apply this customized rendering TV effects, and to combine it, apply on 3D. And Even more, you want to nest the more image effects there. Like here, we added like a blurring together with the customized SurfaceAppearance feature. So now you can get a very interesting and nice results. It's kind of to simulate a, kind of like a blurry glass effect. Yeah, you can do a lot of more things like this. So here's another example about things like video effects. So we have a video, took it from example data. And then what we do is just apply SurfaceAppearance to this RAS box. And it should just works. And this is the original video, and this is applying edge detection. I just want to mention that all the computing happens on GPU in real time. This is a very large image size video, and you can tell it happens in real time. Yeah, so you can do a lot of fun things there as well. So the one thing I want to mention that surface appearances are very transparent. If some of the features added or somebody else added, if you were interested, kind of like a WebGL, you can see all the details there. Like this is the TV. The TV effect, bad TV effect there. This is a fragment shader. You can see where this file coming from, and also have some of the how it is implemented, some random numbers generator. Yeah, you can just take this all this information and play with it, and you will get something nice. Yeah. So last, in general, what SurfaceAppearance can bring us. Apparently, through all the examples, I showed that you can do customized rendering with it, and you can apply the GPU program to combine it with our existing Mathematica functionality. It does not. It can work together if you do it correctly, and it also potentially could be helpful to move computing from CPU to GPU, and like for example the video effects you're seeing, and also reduce the data transfer cost, like because you just transfer the original data, and also and a piece of the program instead of the pre-computed data. So as long as you are doing following the GLSL standard, if you make it work on one machine, and we can guarantee that it will work on all machines, that you don't need to worry about the hardware, like different vendors, NVIDIA, AMD, or Intel, or different versions of driver, or different platforms like Windows, Mac, and we will just make sure it works. And so it has great potential that it just makes things much easier to adding new features, and yeah, that's a possibility it brings. So I think that's my mainly my talk. I think I still have some time, and I will go through the Q&A if there's any. How will these feature work in server environments? without hardware support like Mesa. From Jeff. Hi, Jeff. So all these things working fine, and we have Mesa, and yeah, we all these features will just work there. It is guaranteed. And all the features we introduced, we are tested against the Mesa version we had, and it should just work with all Alpha and Wolfram Cloud. Yeah. So okay. Yeah, that's the only question. So we don't have other questions. So yeah, that's it. So enjoy the rest of your talks.